Unit 7 Solutions. Content 7.1 Types of solutions 7.2 The solution process and solubility 7.3 Ways of expressing concentration of a solution 7.4 Describing reactions in solutions 7.5 Colligative properties of solutions. Seven point five Colligative properties of solutions. When a solute is dissolved in a solvent, the properties of the solution differ from those of the pure solvent. Properties that depend on the concentration, number or amount of solute particles, molecules or ions, and not on their kind are referred to as colligative properties. The most important colligative properties of a solution are vapor pressure lowering, boiling point elevation, freezing point depression or freezing point lowering, and osmotic pressure. Colligative properties of non-electrolyte solutions. The extent to which the properties of a solution are changed as compared with the properties of the pure solvent is stated by the colligative property law. The law states that the vapor pressure, boiling point, and freezing point of a solution differ from those of pure solvent by amounts that are directly proportional to the molar concentration of the solute. A hypothetical solution that behaves exactly as described by the colligative property law is called an ideal solution. Most solutions approach ideal behavior only when extremely dilute. 7.5.1 Vapor pressure lowering. When a non-volatile solute is dissolved in a solvent, the solvent's vapor pressure is lowered. Solutions containing non-volatile liquids or solutes, as solutes always have lower vapor pressure than the pure solvents. The concentration or number of solute molecules in a given concentration or number of solvent molecules can be expressed in terms of mole fractions or molar concentrations. The lowering of vapor pressure associated with non-volatile solutes is summarized by Raoult's law. Raoult's law states that the vapor pressure of a solution is directly proportional to the mole fraction of solvent in the solution. This relationship can be expressed algebraically as P is equal to P degree X, where P is vapor pressure of solvent, P degree is vapor pressure of the pure solvent, and X is mole fraction of the solvent. The vapor pressure of the solution P is equal to the vapor pressure of the pure solvent P degree multiplied by the mole fraction of solvent in the solution X. Since X is always less than 1 for a solution, the vapor pressure of the solution containing a non-volatile solute, according to Raoult's law, is less than that for the pure solvent. The vapor pressure of a solvent in a solution decreases as its mole fraction decreases. By using Raoult's law, we can obtain vapor pressure lowering change of P. Change of P, P degree minus P. Change of P, P degree minus P degree X. Change of P, P degree times 1 minus X. P which is equal to P degree X by Raoult's law. From mole fraction definition, X plus X minus solute which is equal to 1. X solute which is equal to 1 minus X. This X is X solvent. Change of P which is equal to P degree X solute, where change of P vapor pressure lowering, P degree vapor pressure of pure solvent, and X solute is mole fraction of solute. Figure 7.10 depicts the relationship between the vapor pressure of the solution and the mole fraction of a solvent in the solution. At the volume up is the vapor pressure. Here on the curve obliquely or slant vapor pressure of pure solvent. Example 7.31. Calculate the vapor pressure of a solution containing 4.57 gram of glucose dissolved in 25.2 gram of water at 25 degrees Celsius. What is the vapor pressure lowering? The vapor pressure lower of water at 25 degrees Celsius is 23.8 millimeter of mercury. Glucose has negligible vapor pressure. Here we have a solution. To find a mole fraction of solvent, the number of glucose, 4.57 gram divided by 180 gram per mole, which is equal to 0.025 mole, and the number of mole of water, 25.2 gram over 18 gram per mole, which is equal to 1.40 mole. Number of solution total. Number of glucose plus number of water, 0.025 mole plus 1.40 mole, which is equal to 1.425 mole. X is the mole fraction. Here 1.40 mole over 1.425 mole, which is equal to 0.982. And then mole fraction of glucose, 0.025 mole over 1.425 mole, which is equal to 0.018. Here P, which is equal to P degree X, which is equal to 23.8 millimeter mercury times 0.982, which is equal to 23.4 millimeter mercury. Vapor pressure lowering, VP lowering. Method 1. The vapor pressure lowering, change of P, which is equal to P degree minus P, 23.8 millimeter mercury minus 23.4 millimeter mercury, which is equal to 0.4 millimeter mercury. And the method 3. Method 2. Change of P, which is equal to X glucose, change of P degree, 0.018 times 23.8 millimeter mercury, which is equal to 0.4 millimeter mercury.